Hi guys, this is going to be a short and sweet video about whether two ratios are proportional to each other. Oh, and at the end, I'll share my visual toolkit with you so you can screenshot it and put it to good use when simplifying ratios. This topic is nice and straightforward, so without further ado, let's dive in. Sometimes we are asked to check whether two ratios are proportional to one another. All this really means is one ratio just a scaled up version of the other? As a simple example, let's take a look at a ratio of 1 to 2. Which of these other ratios are proportional to it? You can probably tell just by looking, but questions won't usually be this simple, so let's do it properly. If we scale up our ratio by a factor of 2, we'd get 2 to 4. So 2 to 5 is not equivalent and hence is not proportional. And if we scale up our original ratio by 3, we'd get 3 to 6. So 3 to 6 is proportional and 3 to 5 isn't. Here's an example for you. Farm A has 2 farmers and 6 donkeys. Farm B also has only farmers and donkeys. Out of a total of 20 living beings, 16 are donkeys. Are the ratios at the two farms proportional? Incidentally, my dad's nickname for me as a child was Donkey. Stick around to the end and I'll let you know why. Right, let's have a go at this in fraction format. Our first farm has a ratio of 2 farmers to 6 donkeys. For farm B, we are not given the farmer to donkey ratio directly. We need to work it out ourselves. It's straightforward enough. If there are 20 beings in total and 16 are donkeys, then 20 minus 16 gives us 4 as the number of farmers. Hence, our ratio for farm B is 4 over 16. Let's simplify both of these ratios. Farm A is 2 over 6. If we divide the top and bottom by 2, we get 1 over 3. For farm B, we have 4 over 16, which, if we divide the top and bottom by 4, simplifies to 1 over 4. We can see that 1 over 3 and 1 over 4 are not equivalent, and so the answer is that the farms are not proportional. Another way to do this without simplifying is to look for a common denominator. So for 2 to 6 and 4 to 16, we look to a common factor of 16 and 6. 48 is the lowest common factor, so let's convert each ratio to have a denominator of 48. For the first ratio, 6 needs to be multiplied by 8 to get 48. Therefore, we also need to multiply the top by 8, and 2 times 8 is 16. Looking at the second ratio, 16 needs to be multiplied by 3 to get to 48. Also multiplying the top by 3 gives us a ratio of 12 to 48. 16 to 48 does not equal 12 to 48. So again, the farms are not proportional. When they are not proportional, we can deduce other things. In this case, farm A requires more farmers per donkey than farm B. So look out for questions that ask this sort of thing rather than simply, are these two ratios proportional? Here's a quick note of caution. When comparing ratios for equivalence, we need to make sure the units on the top of each ratio match, and the units on the bottom of each ratio match. If you want a toolkit for how to simplify ratios to make them easier to compare, then check out our Simplifying Ratios video. I'll stick a link in the description. And if there's anything else you'd like me to cover in a video, let me know in the comments. Okay, your turn to have a go. I've got 2 questions for you. Check whether the following pairs of ratios are proportional to one another. Use ratio or fraction format. Don't start the video again until you've attempted both. Okay, pause the video now. Right, I hope you've got your answers ready for these 2 questions. Let's see if we agree. Okay, let's start with the first question. I'll attempt this one using ratio format. We have our 2 ratios. Let's call them A and B. The first thing I notice is that we have a difference in units between the two ratios, so I'll sort them first. If you saw the simplifying ratios video, you might remember that it is often easier to convert the larger unit to the smaller unit, so that you don't end up with decimals. Here, we have meters and centimeters. Meters are bigger than centimeters, so I'll convert those. There are 100 centimeters in 1 meter, so 3 meters becomes 300 centimeters. We also have kilograms and grams. Kilograms are larger than grams, so I'll convert the 4 kilograms. And there are 1,000 grams in 1 kilogram, so this becomes 4,000 grams. Cool, we've now got matching units. We now need to check whether the ratios are equivalent. A safe method is to simplify the ratios. If the ratios are proportional, their simplified versions will match, so let's do that. We can easily see that ratio A divides by 100, leaving 3 centimeters to 40 grams as its simplified version. Moving to ratio B, I can easily divide both sides by 10. This leaves 6 to 8. And these are both even, so I know I can divide further by 2. And that leaves me with 3 centimeters to 4 grams, which can't be simplified any further. So now we can see that these two simplified ratios do not match, so they are not proportional. As you get more confident with manipulating and simplifying ratios, you'll probably be able to spot ways to check for this equivalence earlier in the question, which can save you some time. Let me explain. Let's go back to the question when we have just made sure our units match. For ratio A, we have 300 centimeters, and ratio B, we have 60 centimeters. You might spot here that we can divide 300 centimeters by 5 to get 60 centimeters. So let's do that to ratio A. 300 divided by 5 is 60 centimeters, and 4,000 divided by 5 is 800. And just as a quick tip, to divide by 5, I generally divide by 10 first and then multiply by 2. 4,000 divided by 10 is 400, and then 400 times by 2 is 800. So we now have ratio A as 60 centimeters to 800 grams. Because 60 centimeters is the same in both A and B, we can now check for equivalence. And we can easily see that they are not equivalent because 800 grams is not equal to 80 grams. Same answer, but a bit quicker. Let's move on to question 2. I'll try this one in fraction format. A key to this is recognising that 120 miles per hour is indeed a ratio. It is 120 miles per 1 hour. I've got a great video on the word per, by the way. Check it out in the description. So we can write it as a fraction like this. And our second ratio is 2 miles per 1 minute. Our units on the top match, but on the bottom we've got hours compared to minutes. So let's convert the larger type to the smaller type. There are 60 minutes in 1 hour, so our first ratio becomes 120 miles per 60 minutes. If you don't immediately spot a common factor of 60, you should be able to spot that these can divide by 10, top and bottom. Then we can see a common factor of 6, so dividing top and bottom by that gives us a ratio of 2 miles per 1 minute. This immediately matches our second ratio, so we can see that the two ratios are proportional. Did you manage to get the same answers as me? You might have used a different format or simplified in a different order, but that's totally fine. With ratio questions, there's usually more than one way to skin a cat. We're near the end now, and I promise to tell you why my dad's nickname for me as a child was Donkey. The truth is, I don't actually know why, but he always called me that. Well, that's us done for today. I trust you now have the skills and confidence to tackle these types of questions. I've already mentioned a ratio toolkit that I put together for a previous video. I thought I'd just show it to you quickly now so that you can take a screenshot if you want. It will be available as a flashcard, and if you want to see how to use it, go and check out our Simplifying Ratios video. Until next time, the only thing that remains for you is to like and subscribe. And for me is to say, Al Civvy.